Okay, in this lesson, we're going to learn how to graph square root functions and cubic root functions. And again, the main objectives are able to graph it and then determine the domain and range and also figure out the starting point. Because you're going to see another video later on that talks about how these graphs are all related. And so we're just going to kind of introduce these two and tie it back in with other ones a little bit later on. So first, let's take a look at the square root of x. Now, with all graphs, if you're not really sure what it looks like, you can always just start with the xy table, input, output. So remember, an input goes over here, and you plug in a certain number. So, we could plug in 0, 1, and so forth. So what's the square root of 0? 0. The square root of 1, 1. Now, again, it wouldn't make sense to put 2, because what's the square root of 2? Well, now you have an irrational number. So what's the next perfect square? Put a number in that makes sense. Put in perfect squares. So the square root of 4 is 2. The square root of 9 is 3, and so forth. So now if I graph these points, I got 0, 0, 1, 1, go over 4 and up 2, go over 9 and up 3. So now we have this pattern that looks like this. So again, if I write this out, go over 1, up 1. We go over 4 and then up 2. We go over 9 and then we go up 3, okay? So we're stepping by perfect squares. And notice vertically we're stepping up one at a time. So talking about domain and range, well, where does the graph exist? Well, let's shade in the area we want. Notice the graph is only in the first quadrant, okay? So it's this area over here. And notice what we have here is, what domains exist? Well, x values that are bigger than or equal to 0. So x values that are greater than or equal to 0. And then we have y values for the range that are bigger than 0 as well. So y values bigger than or equal to 0. So this is your range, as well as the blue down here is your domain. Okay. So that is what we're talking about for domain and range. Okay. Notice that's the only part of the graph where it exists. You can kind of go where it starts from and what direction it goes to. Okay. Now, let's take a look at how this applies to other things. Notice we have this form right here. Now, notice this looks a lot like what we saw before with parabolas and quadratics. X minus h quantity squared plus k. And notice we had a starting point of h comma k, and then we had a scale factor of a, and that's your scale, okay? And here again is your start point, hk. So let's take a look at a couple examples. So first thing I'm going to do is draw in my base graph. So again, I'm going to start at 0, 0, go through 1, 1, and go through 4, 2, and go through 9, 3. So there's my curve. In fact, I'm going to draw it a little smoother. That's a little better. Okay. So now it's our base curve. So let's take a look at the next example here. So notice we have a starting point. If I was to rewrite this, okay, it's going to be the square root of x minus 0 plus 3. So now we have a starting point of 0, 3. Notice by looking by what's inside the radical. So I'm going to start at 0, 3, and that's like our new starting point. So now it's the equivalent of taking the base graph and moving it up to this area right there, okay? And notice now we also have a scale factor of 3. So what does the 3 do here? Well, instead of going up, let's look at this graph here, going up by 1, 2, and 3, we're going to multiply those by a. So we're going to go up over 1 and up 3, over 4, and then up not 2, but 6. So notice the curve is now going to be steeper to go through that area here. So this dimension here is 1 up by 3. This dimension here is 1 up by 6. Okay? And notice the difference there. Let's take a look at another example. So in this one here, we have a starting point. I put a k value in, it's 0 because it's not shown. So we start at 4, 0. So let's write that down. So over 4, 0. And notice we have a negative value here. So I'm going to move my base curve down to my new starting point. And again, my starting point is kind of like right there, my new origin, for a lack of a better word. And being that it's -2, we're going to go over 1 and then down 2. And then we're going to go over 4 and then down -4. Okay, so we're multiplying everything by -2. So now we have a curve that does that. Okay, so now we can see the difference. So it's the same curve, just different location and different scale. Okay, so again, if I had to point out, a couple things here, is number one is starting point. Number two is type of curve or line. Okay, so the type really is what I want to say. And then three, the scale. Okay, is it a steep? Is it shallow? Whatever the case is. So again, let's talk domain and range. So for this one here, the domain value is all x values bigger than or equal to 0. And in the range, notice it's moved up. So y value is bigger than or equal to 3. For the green function, we have domain of x values bigger than or equal to +4. And then the range is y values less than now 0 because it's upside down. So that's what we're looking for in that one. Let's look at the cubic root of x. So again, let's come up with a table. X, y. So plug in values is 0. The cubic root is 0, 0. Cubic root is 1 is 1. Now again, what's the next perfect cube? That's going to be 8. What's the cubic root of 8? 2. Okay. And as well as, we can see the same thing for -1 and -8. And we have negative values because we have an odd root. Okay. So let's take a look here and graph this. So we have 0, 0, 1, 1. And then we have 8, 2, and the same thing on the negative side. So -8, -2. And notice we have a curve with a little switch here in the middle. Okay, a little turning point there. So what's my domain and range being at? It's odd. Most likely it's going to be all real numbers. Okay, and that's going to be the same for much all odd functions. Let's take a look at some examples. Again, let's draw a base graph in. So I'm going to start over here. Go through -8, -2, go through 1, do a little switch, and out that direction. So there's your base curve, okay? And I just sketched it in there. Now let's take a look at our function. So notice we have plus 0k, so there's our hk of 2, 0. So I have a starting point of 2, 0. So there's our new starting point. So if I take our base curve and move to that point, what do we have? Okay. Well, now we have a scale factor of 2. So instead of going over 1, up 1, I'm going to go over 1, up 2. And now I'm going to go over 8, and then not up 2, but up 4, because everything's twice as tall. So notice, if I'm drawing the red curve right above the black curve, it's the same curve, but now stretched twice as tall. And we're going to add the same thing on this side over here. Okay. 2, 4, 6, 8. I'm just going to get my points in the right position, and notice we have a curve that looks like that. And again, domain and range are all real numbers for this case here. Okay. Let's look at one more example. And I notice this one. I'll do this one in green. Okay. And we're going to have a starting point of 0, 5. So I have a value up here. That's our new starting point. So let's move our base curve there. Again, I just do that so we have a reference of what we're kind of looking for. And being it's half as tall, okay, what we're going to have is going over 1 and up a half. Going over 8 and up only 1, half of 2. And notice how shallow it is. It's only half as tall as it was before. So it's a little more shallow of a curve. So even with the fractions, it gets a little shallower. All right, so there's some introduction to square root and cubic root functions. I want you to try this equation, and feel free to just draw in the same graph, and or on a separate graph. It's up to you. And then I'm going to go back one slide here, and I want you to go ahead and try. Let's move this out of the way, just for the time being. And let's go ahead and have you try this function here. Okay, one I just pulled out, labeled you try.